We are going to look at a one proportion test, and the problem states that 9 out of 10 doctors recommend aspirin when their patients complain of headaches. A group of researchers just decided that they didn't really believe these results, or that they wanted to test those results to determine if that was accurate. So they decided to choose a random sample of 150 doctors and to ask them if they would recommend aspirin in this situation. And of those 150 doctors, 133 indicated that yes, they would recommend aspirin. So we want to determine if the results of the survey were accurate. And we're going to say that the group of researchers did not believe this. So they want to prove that less than 90% of doctors recommend aspirin in case of a headache. So our statement, we're just going to restate that question, and we're going to say less than 90% of doctors recommend aspirin for patients with headaches. Our hypothesis, we're going to be testing proportions and not means, so we're going to use the letter P. Our null is that there is no difference between the survey group and the group that we sampled, so we're going to say that both proportions are equal to 90%. Whereas our alternative is that our proportion was actually less than 90%. So of the sample we conducted, we think that less than 90% of doctors actually would recommend aspirin. So let's go over to our StatCrunch, and we're going to go to Stat. We're using the proportions test, and we have a one sample because we're only looking at a sample that we conducted, and we're comparing it to that specific proportion. And because we are given the proportions and the numbers, we're going to do with summary. We're not given a data table. So with summary, our number of successes are the number that actually would recommend the aspirin. Our number of observations is our sample size, which is 150. And we are going to run a hypothesis test. We are comparing it to 90%, so our null is that our proportion is equal to 90%. Our alternative is that it is less than 90%. So it should look just like mine. Click next and then just calculate. You'll be given a table that looks just like our tables when we were doing our t-test, except this time we're looking at the proportion. We are given a p-value of 0.29. Again, we want to compare that to our alpha of 0.05, meaning that it happens by chance only 5% of the time or less. In this case, we have a p-value of 0.29, which is much greater than alpha. This 0.29 tells me that 29% of the time, if I would do this survey, my results would occur by chance. So my 0.29 tells me that I failed to reject my null hypothesis, and I can draw no conclusions on my data, meaning I cannot say that it's either greater than or less than 90%. I just failed to draw any conclusions.